today's video, we're going to talk about strategies for cracking the meta interview loop, the coding interview loop in particular, in 2024. We're going to break things down into what are these sort of conditions you face in the meta interview loop and what strategies you should use to overcome, the challenges. So the first one is the tight time constraints. If you have the interview coming up, your recruiter must have told you about the format. I'm just going to jump down to the fact that you're going to have 35 minutes for 2 coding questions, and you're going to find that you have little or no thinking time. But the good thing is that they're quite tolerant about bugs. So let me step back a bit. Little or no thinking time, tight time constraints, meaning you have to code very quickly, but they're not too strict in terms of bugs. That doesn't mean you can forget to handle a division by 0 or miss an important edge case, but if you have some minor syntax issue, then that's not going to be the end of the world. So what do you do? How do you deal with this? So one thing we've noticed is that candidates who do this practice can be quite tactical, where they might get a first question, and if that first question isn't going so well, they can actually just ask the interviewer to move to the next question so they can come back to this. And the idea is you want to solve the question you can handle first, get that momentum going, and then focus all the other effort on the next question. But more specifically, the way meta interviews is more like speed chess versus, say, okay, we're trying to see how this candidate thinks and how they problem solve. Even if they say they're looking for problem solving skills, they're literally not giving you time to think. So it's more like speed chess. So you need to train under these tight time conditions. But just to be very clear, you should definitely take that time, especially if you're in the beginning phase, to understand the fundamentals of data structures and algorithms, solve some problems under no time pressure. But once you've got a solid grasp of the key concepts, then you should definitely focus on then practicing, for the interview. So you're actually training on an interview condition, solving, 2 questions in 35 minutes and being very tactical in how you do so. I would also recommend you, at some point, practice with an interviewer, a human interviewer, ideally in the loop, because that's more closer to what you're going to face. And then in terms of minimizing your mistakes, I'll recommend this technique called incremental chunking. And this is just a fancy way of saying, look, you have your algorithm that you've decided you want to implement it, and you just put guardrails. And the way you can do that is you break your algorithm into different phases, into different chunks, and lay it out with skeleton code. And the idea is, once you implement each chunk, that's your algorithm. So when you're doing your implementation, you just have to focus on one chunk at a time and don't have to keep your whole algorithm in memory. And you're less likely to make mistakes that way. The next thing we're going to talk about is the fact that Meta, at least in 2024, they recycle questions. If you know anything about Facebook, if you've seen the social network, or even if you're aware of this Threads, which is, at least from Elon Musk's perspective, a copy of Twitter, not my words, you will likely get questions that are carbon copies of things they've asked before, or variants of those things. And some people get excited when they see this, like, oh, I got a question that was similar to what I saw before. But this is actually a double-edged sword. It can be a positive and negative. There's actually a lot of danger when you're solving a problem you've seen before, and I'll come to that. And it's about this thing I call autopilot. The idea that if you spend a lot of time solving a problem, and you've I don't want to say you've memorized, but it's in your memory. If you see a lot of similarities to something you've seen before in the problem description in an interview, then your brain is going to replay the past. And you can, if there's a subtlety in the difference or a variant, your brain might easily omit that, and you might just go off and be solving the problem you've seen before, as opposed to handling whatever is unique to what you're facing. And by the time you realize this, if you realize it, you might be out of time. So you have to have a way of controlling autopilot. One of the things I'll recommend is don't memorize solutions. Have like a thought process chain that you can follow. In your interview, use checklists so you can highlight the key subtleties about the problem, key things you need to address. The skeleton code strategy I mentioned earlier is also useful. But just going back to how you deal with these repeat questions, let's say you don't have this autopilot issue, I would say that because of the tight time constraints, you definitely want to familiarize yourself with the type of questions they ask, because even if you get a variant, typically the theme, the context, and all these kind of pieces of that theme that you kind of need to understand to solve the problem are typically quite similar. So for example, there's this popular asteroid collision problem. It's about asteroids colliding, and if some asteroids are moving in the opposite direction, they'll never hit, but if they're moving in the same direction, then they can collide. So if you've already familiarized yourself with all of that, you don't have to think through that on interview day. You can just focus on actually solving the problem and whatever the variant might be, like handling that. So the idea is that you familiarize yourself with a lot of these meta-style questions and you cache these things in memory so that on interview day, you can just focus on solving the problem. A lot of people do solve hundreds of past meta questions. I would say that's a good idea, but I would say you want to be very efficient. It's a good idea because they have a pool of questions and they pull out from that pool, and if you solved the more of the questions you solved, the more likely you get a collision in your phone screen and your on-site. And if for all questions you face you've seen a variant of something before, odds are you will most likely be able to get through that question in interview phase if your fundamentals are good. But the efficiency side I want to go to is when you're going through these problems. So let's say you want to solve 400 meta problems. Don't literally solve 400 meta problems. You can go through them mentally and see if you can actually lay out a solution pathway. If you're stuck after like 5 minutes, check the solution and see what your knowledge gap is and plug it. And you can do that for hundreds of problems. And then you can then prioritize which ones you want to solve. And even when you're solving these questions, I would recommend, like for example, you already know how to write a for loop. You already know how to write a while loop. You already know how to do, look up values in a hash table. So at some point, these things are second nature to you. If you're going to have to do this 100 times or 200 times because of you're solving 200 problems that require this, then that's not good use of your time. So you can just, for those kind of boilerplate things, you can basically use AI as autocomplete. So I would recommend, get a code editor with an AI assistant like, VS Code with the Copilot. And when you're looking at these problems, just lay out your solution with comments and only implement the part you're not comfortable with. But for boilerplate, standard stuff, let AI take care of that because you already know how to do it. You can mentally do it as well. And this allows you to cover more problems in less time and identify what your gaps are. So you can prioritize those and plug them. And this will help you get ready faster. So I'm not saying don't solve. I'm saying don't solve straight away. You can solve after, but at least do these prioritization, do this mental solving, spot your weaknesses, spot your gaps, and be as efficient as possible. Let's talk about the chances of success in the meta interview loop, again, specifically on the coding round. At Coditioning, we help quite a lot of candidates with this process, and what we find is it's pretty much bimodal in terms of the distribution, the probability distribution. I'm not going to go into all the maths on probability, densities, and so on, but what we'll say is, what we find is there's two camps, and it's kind of pass or fail with little room for middle ground. This is just our observation. For candidates who obviously prepare well and get lucky, and by lucky we mean the questions that they meet on the interview day are recycled questions, basically questions they've seen before or variants. The chances that they actually are able to get to an optimal solution in a tight time frame is very high, and they tend to get higher decisions. Whereas in the other camp where maybe they didn't practice so well in terms of getting high coverage of past meta questions, or they were just so unlucky that maybe one round had a question they hadn't seen before, and it was, as you can imagine, wasn't something they could figure out in the time available, they tend to get a no higher decision. So there's a lot of luck involved in the process, which is very unfortunate. And what you're going to try and do to boost your chances is increase the odds of a collision. So the odds that the probability that you'll see questions you've seen before. It's a bit unfortunate that this is the process, this is a game, but this is kind of what we recommend you do. If you like the video so far and you want to get notifications, be sure to like, subscribe, sign up for the notification button on YouTube. Of course, if you think your friends benefit, share. We also have a Discord channel and an official website, but more on that later. The next condition you need to be wary of is with regards to code execution. So when people tend to practice on LeetCode or whatever other platform, I find that they run their code multiple times till they get a correct solution. In the meta interview, you're not going to be able to run your code. Like, code execution is actually not allowed. So you need to be good at dry running your code. And some people do this really badly. There's a difference between reviewing your code and verifying that what you implemented was your intent versus what you implemented is correct. So I'll say the key difference is when you're doing proper dry running, you are using a test case and walking through your code as if you are the underlying engine that runs the code line by line, and you're checking the output of each line and moving line by line and making sure that the end result matches what you expect for key test cases, including edge cases. So just as an exercise, let's consider a problem where you need to evaluate some expressions, mathematical expressions. So we have all these on these lines. They might look complicated. So here's just 1 plus 2. Here we have two expressions, like a compound expression. So we have 1 plus 2 times the other expression, which is 3. So each expression is like in a bracket. But I'm just going to keep things simple, and let's just keep it simple where it's just an integer, some operator like a plus, minus, division, and another integer. So let's say you had to implement a function that evaluated simple expression. It took a left value, it's just an integer, a right value, and then an operator. So here's what sample usage would look like. You call the function 3 plus 4 is 7. If you call the function 3 minus 4 is minus 1. Call the function 3 times 4 is 12. There's also division. So maybe you can pause the video, take some time, quickly implement this. This is very straightforward to do if you've been practicing quite a lot. And then dry run your code without executing it and make sure it's correct. So you can pause the video now and do this. Now, what we find in this kind of exercise, especially when we actually give the full complicated problem, is some candidates will come up with a solution that might look like this. So they get the addition correct, they get the subtraction correct, they get the multiplication correct, but when it comes to division, they forget to handle division by 0, which should be something like this. And I would say in a meta interview, a bug like this is a major bug. This is not like a small syntax issue. But if you're dry running your code just to verify your intent, this might just look good. Well, if it's a division, I do a division. If it's and there's like a pattern here as well that could throw your brain off, especially if you do it in this order, where you say, well, plus you add, subtract, minus you subtract, multiplication you multiply. So this kind of pattern can throw your brain off and make you not even think to handle this division by 0 properly. So it's something you need to be careful with doing. However, if you're running with test cases, if you're walking through with test cases, if you had this situation where your right value was a 0, you get to the point where you'd be like, okay, so the left value is like, let's say 4 divided by 0. That is not allowed. And then you realize, and then add this exception and throw this exception in the scenario, or whatever else you decide to do to handle that scenario. So key point is, make sure you're dry running to verify correctness and not dry running to verify that what you implemented was your what you thought you wanted to do, or you thought was correct. As if it wasn't bad enough that you couldn't execute your code, you actually will most likely gonna have to code on a plain text editor, so you don't get to code with autocomplete or syntax highlighting. And this can be very weird if you're not used to doing that. So definitely, obviously, practice on a plain text editor. You can't execute your code. Practice dry running, after implementing. Practice on the tight time constraints, and practice meta style questions. But for other tips, things you can do, firstly, I'm sure if you have the interview, your recruiter will have shared the key criteria they're looking for. So I'm not going to dive into this right now, but rescheduling is something that's very powerful. So at first, you get a chance to say when you are ready to do your interview. Try to give yourself as much time as possible. But when it gets closer to that time, if you still don't feel ready, And feel is not even the right word. If you haven't proven that you're interview ready, then what I would recommend you do is actually reschedule. And you can do this, you can do this up to 2 times. Just make sure you give enough notice. And Meta are very good with this. So if you're not ready, reschedule. Don't waste the opportunity. It's so competitive that if you're genuinely not ready, you're most likely you're going to mess up. Dynamic programming, although they don't explicitly say this, it's very clear that this is something they pretty much don't ask. So I wouldn't say don't know this, but I'll say deprioritize it in your preparation. Let's put it that way. So I protect myself from lawsuits from you guys. And then the key thing is the hiring bar, which I've kind of alluded to. It's very high. In 2024, what we're seeing is you pretty much have to get a higher decision in every coding round to have a very good chance. If you have one bad round where it's like a lean hire or a soft reject, chances are you're not going to make it through, just based on what we've seen from the candidates that have gone through this year. Borderline candidates tend not to get through from our experience. Things are very competitive in this market because of, the layoffs. There's loads of high quality candidates on the market. So it's a very high bar this year. If you're not already a member of our Discord community, make sure you join. We got over 1,000 members, and we have weekly hangouts. We have workshops on system design, low-level design coding, where you actually get to solve problems, get feedback, get guidance on how to approach these types of problems in interviews, in order to optimize your chances of success. You can even use it to find a study buddy. Also, be sure to check out our website, www.coditioning.com, where we have resources to help you check if you're interview ready, so you can assess your interview readiness. We've got mock interviews with an AI interviewer, company-specific ones for Meta, Amazon, Google. You can do mock interviews with humans. You can get even coached sessions. We have a lot of learning content on different courses, from low-level design to data structures and algorithms. You can create custom learning paths based on your strengths and weaknesses. You can do diagnostic tests. We have crash courses to get you interview ready in a short space of time if you're quite time constrained. Blogs with loads of advice. So definitely check out the site. And hopefully with all the advice, all the resources we're making available, you're going to be this guy or person and not Lex Friedman getting strangled by Zuckerberg, which we're using as a metaphor for Meta. The grind can be it can be quite time consuming to prepare. A Coditioning would try to make it pain-free and fun and not a grind, but I think regardless, you're gonna have to work hard, very competitive. If you check on levels.fyi, you can see what the compensation is at whatever level you're targeting and what the potential is. So I'd argue it's definitely going to be worth it, most likely. And Meta's up there with the top companies in terms of their brand and compensation. I think some people might disagree with other things that they do, but just generally speaking, if you were already interested in Meta, then it's probably worth it from a compensation perspective. So probably worth the effort. So best of luck, and see you in another video. If you like this, you know what to do, and see you soon.